All right, so we're on 3C.12, which is the last section of 3C. On 3C, you're introduced to what we call equivalent representations, which are our identities, okay? From our identities, you do need to memorize them. So starting off with part A, the first identities that you should have been introduced to are your reciprocal identities, which are telling you that sine x equals 1 over cosecant x. Cosecant x is 1 over sine x. Cosine x is 1 over secant. Secant is 1 over cosine. Tan x is 1 over cotangent. And cotangent is 1 over tangent. That's just telling you that, remember how we talked about our x's and y's? Our x, y's, and r's are reciprocated when we're going around the unit circle. This is just putting the trig name to it, okay? Same concept. All we're doing is reciprocating, which means we're just switching our numerator and denominator around, okay? What makes something reciprocal is if you multiply these two together, they're going to automatically equal 1. A reciprocal, two reciprocals are going to equal 1, just like 2 over 1 times 1 over 2, that automatically equals 1. So if these two are ever next to each other, then they're going to equal 1. Does that make sense? So if I'm ever multiplying them, they're going to cancel each other out. Next are your quotient identities. Your quotient identities are tan x equals sine x over cosine x. The thing about an identity is that they can also be manipulated to mean other things. So if I have that tan x equals sine x over cosine x, it also can mean, if I substitute in the reciprocals, I can also create another identity, which would be tan x equals, let me write it. This could also mean that tan x equals my cosecant x over my secant x, because I can substitute the reciprocal identities in and create another identity, okay? And so that's just telling you, hey, this is a relationship. Remember, tan is just y over x. Y is our sine, x is our cosine. And that's all this is saying, is that you have your y over your x, okay? But putting it in words. Cotangent is the reciprocal of tan, which is why it's cosine over sine. So it becomes x over y, and that's all that means, okay? In the same token, using the reciprocal identity, you can create another identity, which would be secant x over cosecant x, okay? All the identities are interchangeable because they're going to make equivalent statement, which is why this is called equivalent forms, okay? Equivalent representation, sorry. Next is your Pythagorean identities. Your Pythagorean identities come from the heart of understanding that x squared plus y squared equals 1. Let me write that a little better. X squared plus y squared equals 1, right? And we know that x and y are our sine and our cosine. So using that, it comes down to being sine squared plus cosine squared equals 1. It doesn't matter that they write sine first. I don't know why they write it first, but it's the same thing. Now, how did this become this? It's because they use your quotient and reciprocal identities to create the other two identities, okay? If you have the free time, you can look and see how they built these other ones, but we don't. But this is the foundation that created these, okay? All they did was substitute in values for sine and cosine to create 1 plus tan squared equals secant squared, and 1 plus cotangent squared equals cosecant squared, okay? With these identities, you can add and subtract across to create their own separate. So for example, on this one, it says 1 plus tan squared equals secant squared. That means that 1 equals secant squared x minus tan squared x. Does that make sense? So I can manipulate the identities to fit whatever my problem may need it to be, okay? Same thing here. I have 1 plus cotangent squared x equals cosecant squared x. Again, I can manipulate it to be whatever I need it to be. So if I needed this to be a 1, 1 can equal cosecant squared x minus cotangent squared x. Identities are just rules that have already been verified, and you can control what those rules look like. Okay, next up were your even and odd identities. For your even and odd identity, it's playing on the role of where things are positive and negative at, right? So when I have a negative a negative angle, that means that we're rotating clockwise. Y'all remember that? So the negative angle means that we're rotating here and going no, clockwise. Okay. So that means where their quadrants where they're still positive and negative are still going to stay the same. Just because I'm rotating different doesn't mean that it's going to change where things are positive. In quadrant 1, all trig value is positive. In quadrant 2, only sine and cosecant are positive. In quadrant 3, only tan and cotangent are positive. And in quadrant 4, only cosine and secant are positive. So when you are rotating, it's telling you how does that affect the sine. So if I have the sine of a negative angle, its sine is going to be negative. That's because it's going to end up in quadrant number 4 or in quadrant number 3. Does that make sense? And in those quadrants, they're going to be opposite of whatever they are. If it ends up in quadrant 2 or 1, it's going to be the opposite of whatever it is because it's rotating the other way. This is just basically an understanding of if you graph it, you'll know whether it's positive or negative. Does that make sense? So it's not like you have to memorize these identities. I can't breathe. It's not like you have to memorize these identities. It's just tying to the idea of that if I am here, I know that is positive or negative. That's it. And just remembering that the negative sign means that you are rotating in the opposite direction. I mean, the negative angle means you're rotating in the opposite direction. All right, so then you should have gone through, taking the notes over that. And then in part B, you were introduced to our sum and difference formulas. So the sum and difference, when we talk about sum and difference, we're referring to sine and cosine. I believe for, what are we? AP Precalc mainly is just focused on sine and cosine. We don't have to really worry about the tangent sum and difference. But sum and difference is just, again, something you do have to memorize. How you choose to memorize is up to you. For me, for sine, I just remember its opposites. So SC plus CS, that's just how I remember. It's just the opposites. For cosine, it's going to be double the same. So it's cosine, cosine, sine, sine. How I remember this is that sine is an odd function, so they're opposite. Sine is an odd, so they're opposite. Cosine is an even function, so they're going to be the same. So how you choose to memorize it is up to you. But sine is an odd function. My snake is odd, right? It has that origin rotation. And cosine is an even function. My cup is symmetrical with the y-axis. But you're alternating your trig, but your angles are staying in the same order each time. All right. Yes. So on cosine, remember how I told you all that x's are liars? I keep remembering that for cosine. Cosine is represented by what? X, right? And x's are liars. So for cosine, when you're finding the sum, you're actually finding the difference between those doubles. For cosine, when you're finding the difference, you're actually finding the sum. So I just remember cosine is an x and x's are liars. It's just kind of how I rolled with it. But that's how, when they did the identities and the theorems for it, it came out to be that they were opposite sides. Okay. It also, yeah. So that's where we're at. And then once you apply, it literally is just plugging in. It's using the identity and plugging in on the double angle formulas. You are following the rules. Sine only has one rule. The rule you use for cosine is totally up to you. And it depends on the problem that you're being given. So you may only want to use the rule with cosine. You may want to only use the rule with sine. You may need to use the rule with cosine and sine if you can see a cancellation. All right. For your test next week over 3C, you're allowed to make a note card. On that note card, even though I'm telling you that you need to have these memorized by the AP test, I'm going to encourage you to write down your identities. Okay. So at least for the test, you can reflect and view them, but for the AP test, you will not be given those identities. Does that make sense? You are allowed to make a note card and write them on there for the test, but for the AP test, we have to have them in our knockout. Yes. Just so that it's the same as everybody else. You got to make it into a note card. Suck it up. All right. Does that make sense? So I'm not making you memorize it for the test, but we do have to work on having these in our brain or being able to use them for the AP test. All right. So now we are at C. Yes. So that was a quick rundown of A and B, and now we're at part C. So starting here, we have sine of x plus pi over 3 plus sine of x minus pi over 3 equals 1. And it wants us to solve for x. What is x? So when we look here, we're going to solve it algebraically. And then we're going to talk about if this is a problem that's on the calculator side, how can I solve this with the calculator, right? But if it's on the non-calculator, what is my answer going to look like? And if it's on the calculator, what will my answer look like? Got it? All right. So up first here, we notice that we have the sum of sines. Do we see that? So these are both, this is a sum of sines, and this is going to be the difference of sine. Sine is opposite, which means that I'm using a combination of sine and cosine. Does that make sense? So it's going to be your sine times your cosine minus your cosine times your sine. Yes? So we're going to set that up by writing these, expanding these out. So when we're expanding, I'm going to start here. This is going to be the A of this one, the B of this one. And this will be the A of this one and the B of this one. So we're going to expand the first part. So for the first one, we have the sine of x times the cosine of pi over 3. Y doesn't lie, so plus the cosine of x times the sine of pi over 3. So that's the first one. Agree? Anyone confused on where that came from? Are we okay? All right, now we're going to do the second one. The second one is going to be subtracting. I'm going to do it below because I'm not going to have enough room. So I have plus, and we're going to do the sine of x cosine of pi over 3 minus cosine of x times sine of pi over 3. And altogether, this has to equal 1. Now, after you've gone through and expanded, you're going to plug in what you do know. And at this point in time in our lives, we should know what cosine of pi over 3 is and what sine of pi over 3 is, correct? So we're going to plug in those values. So plugging in what we do know, we know that we have sine x. What is cosine of pi over 3? 1 over 2 times 1 over 2 plus cosine of x. And what is sine of pi over 3? Square root of 3 over 2. Agree? Okay, and we're going to keep going. So now it's going to be plus the next one. And we have sine x of cosine of pi over 3, which again is it's going to be 1/2, right? Cosine of pi over 3. And then minus cosine x. And sine of pi over 3 is square root of 3 over 2. I'm writing it like this on purpose so that you can see what happens. I have a plus and minus of exactly the same thing. What are they going to do? They cancel out. I have a plus cosine of square root of 3 over 2x, and I have a cosine x of square root of 3 over 2x. So they are opposites, so they're going to cancel out. I have half of a sine x and half of a sine x. What does a half of a sine x make? A half and a half makes a whole. So I have a whole sine x. So once I plug everything in, I'm left with sine x equals 1. So I'm asking myself, when does sine x equal 1? Well, myself is going to like, that means I'm asking for when does y equal 1, right? So when is y 1 on my unit circle? At pi over 2. So x would equal pi over 2. Does that make sense? Okay, let's talk about how this would look on a graphing calculator. Let me open up Desmos. All right, so in Desmos, if I wanted to solve this, I would be putting in the left side and the right side, but I'm going to adjust my window. The window it says is from 0 to 2 pi. So I'm going to change my interval so that this is only from 0 to 2 pi, which means I just need to change one side. I can't really see it, but I'm going to hope I'm writing 2 pi. I did. Okay. About now. Is it now 2 pi? Okay. And I'm going to count by pi over 2. All right. Are you with me? So this is the window that I'm looking at. I'm going to graph what it's asking me. So my left side said sine of x plus pi divided by 3 plus sine of x minus pi divided by 3. So that's my function. And I want it to be equal to 1. So I got to type in y equals 1. And at what point did that hit? At pi over 2. So are we geniuses or what? We are. We're geniuses. So we graphically showed how we know we're smart. We did it. Oh my God. So we adjusted the window based on what it told us. We literally graphed our left side, and then you take your numerical value and set it equal to y, and then you're just looking for where they intersecting. And on our window, they intersect here. Outside of this window, are they going to intersect again? Yes, because it's a circle. You're going around and around. But do we care about the outside of this window? No. That's why we adjusted our window first to begin with. Got it? How do we feel about this example? Do you feel like it's something you can do on the non-calculator and on the calculator side? Maybe? A little bit? All right. Okay. So let's keep her going. All right. So now we're on to number 14. Number 14, it says find the solution of the equation from the interval of 0 to 2 pi, and then we're going to verify again using a graphing utility. So this time we have cosine 2x, which is a double angle. Do we see that? So we're going to be using our double angle identity from your Part B assignment, from your Part B notes. So in Part B, you learned that the sine double angle rule is what? What is the rule for double angle? So what does this expand out to become? Waiting for y'all to tell me. So if you go look, so you're looking at sine 2u, right? That's your double angle for sine. What does it say it expand out to become? So it becomes 2 sine x cosine x plus cosine x equals 0. Okay, those are identities. They're rules that you can use to substitute values in. That's all it means. Think of this as a giant puzzle. And these are all your identities are your puzzle pieces. And your job is to figure out which piece fits into the problem to make it work. Okay, so in this case, we had double angle. So we did sine double. So our sine double angle tells us that in our rule, we had sine of 2u equals 2 sine cosine. That's it. That's the rule, correct? And now I substituted that in. Now that I substitute this in, you now have to use your algebra skills in order to start solving this. All right. Algebra skill number 1 tells me that if I have something equal to 0, in order to solve them, I need to create factors. Factors means I have something times something in order for me to use that zero product rule. Okay. So in order to use that, I'm going to have to factor out what they have in common. And what do they have in common? Cosine x. So I'm going to factor out cosine x. And when I factor out cosine x, I'm left with 2 sine x plus 1 equals 0. The reason why you want to create a factor is because now you have to separate and solve them as separate problems. So I can now solve them as 2 separate problems. So one problem is going to be cosine x equals 0. And then the other problem that I got to solve, it's going to be 2 sine x equals 0. Okay? So we're going to be solving two separate problems to get our x. So let's write our two separate problems. So I'm going to write the easiest one down here. Cosine x equals 0 is problem number 1 we have to solve. And our other factor we had was 2 sine x plus 1 equals 0. That's our second one. So on the first one, cosine x equals 0, what are we asking ourselves? Where does x equal 0, right? That's the conversation we're having in our head. Where does x equal 0? So between 0 and 2 pi, where does x equal 0? At pi over 2 and 3 pi over 2. So we know from this one, those are our possible answers. Does that make sense? So this one is done. Now we're going to go to the second one. The second equation, before we can ask ourselves anything, we have to get sine x by itself. What are the steps I need to take to get sine x by itself? Subtract 1 and divide by 2. So subtracting 1 gets rid of that term, and dividing by 2 gets rid of that coefficient. So we're left with sine x equals negative 1 over 2. When I see this, I'm asking myself what? Self is saying what? Where does y equal negative 1 over 2? That's what self is asking. And self is like, bro. It's either in quadrant 3 and in quadrant 4, which is puts us where? Like that. So we're looking here. So normally, can I use this circle here to make sure we all understand? No, in the video you can't see the circle, but we're going to the unit circle. All right. This is where in quadrant number 1, we would have a positive 1/2. Agree? Y would equal positive 1/2. So this is going to be our 30-degree reference angle. So we're looking for the 30-degree reference angles in quadrant 3 and in quadrant 4 because we need a negative y, correct? So my negative reference angle would be here, and my other one would be here. Does that make sense? So we're counting, that's our 6's, right? So that's where we would have our different 6's. So this is 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6. So it's 7 pi over 6, 8 6, 9 6, 3 6, 11 6. Do we see that? So it'll be at 11 pi over 6 and at 7 pi over 6. That's because in quadrant number 1, that's where I would have a positive 1/2. So I need to look at quadrants 3 and 4 for the negative 1/2. So we're using our 30-degree reference angle. Does that help? Does that make sense how the unit circle to help you guide yourself around? Okay. Everything is based off of quadrant 1. So quadrant 1 is your home plate. Okay. And that's where you're going to take that information all the way around. All right. So for when we're looking for y equals negative 1/2, we're looking for in quadrants 3 and 4, and in 3 and 4, that two angles that have a reference angle of 30 degrees are going to be x equals 7 pi over 6 and x equals 11 pi over 6. Does that make sense? Are y'all with me? All right, so let's go see. How does this work? So we're going to, again, practice checking ourselves in the handy dandy calculator. So here it is. I'm going to reset this bad boy. I'm going to put in my original. So on the right side, we had y equals sine 2x plus cosine x. Helps if I write x. All right. I'm going to adjust my window because I only want to look from 0 to what? 2 pi. So I'm going to go over here, and I'm going to adjust this to try. Hopefully that's it. 2 pi. And then I'm going to count by pi over 6 so I can get all parts of the graph. All right, so we're looking for when y equals 0. Essentially, that just means we're looking for the what? The x-intercepts. And so we have 1 here at pi over 2. Did we get that correct? Oh my gosh, we're geniuses. We have 1 here at, oh, we're so smart. We have 1 here at, and we have 1 here at 11 pi over 6, okay? The tricky part about the calculator is that the calculator can give you your answer. It's about you using it correctly and setting the parameters. Does that make sense? So I'm going to strongly encourage you, when you're using trig in the calculator, it is best to have it count by pi over 6. Or if you notice that it's quarters, then count by quarters. Therefore, it's going to give you those exact values because this is the mode that your calculator will be in on the College Board test. So what you're typing in and telling it to do is what it's going to produce. If you don't make those adjustments, when you try to do this, it's going to give you decimal answers. And what we're looking for those decimal answers. No, we wanted those exact values, okay? All right. And I know that we were looking for the y-intercept, but it's easier, in my opinion, if you graph it as y equals, because then it's going to find that point of intersection and it'll hold it for us. Okay? Yes? Is this helping, making sense? How are we feeling? All right. So as you go through, you're just going to see a variety of identities to continually solve. The identities are just going to keep changing and modifying. So how you solve them is up to you. So for example, here on the next one, we have sine x cosine x equals 1/2. And it says to use the double angle formula. So the double angle formula is when you have 2 sine cosine x. Well, we currently don't have 2 cosine x, but can I manipulate this to say 2 cosine x? Yes. How can I manipulate this? Multiplying both sides by 2. So you have to be ready to take those pieces and alter them. Does that make sense? So when I look at this, I currently have sine x cosine x equals 1/2. And it wants me to use the double angle formula. Well, in order to use the double angle formula, I need to make this into the double angle formula. So I'm going to multiply all sides by 2. When I multiply all sides by 2, I get 2 sine x cosine x equals 1. Now, does that look like our identity? Yes. So now I can condense. So we're going to condense 2 sine cosine x down to sine of 2x equals 1. Okay. So you're looking for what angle cut in half, right? Because you'd have to be able to double it, will equal 1. Does that make sense? Let's say that again. So normally, this would just be x, but it's not just x, it's x doubled. Okay? So we're looking for what angle cut in half would equal 1. Because otherwise, it wouldn't equal 1. So when you're thinking about it, you're looking for when does y equal 1? Where does y equal 1x? When theta is pi over 2, right? And I'm just going to cut this in half. So pi over 2 cut in half gives me pi over 4. So therefore, x would have to equal pi over 4 in order for this to be a true statement. It couldn't be pi over 2 because pi over 2 would now make this into pi. Does that make sense? So the answer would be pi over 4. The problem with these is that I can go through all the different identities with you, but because there's infinite possibilities of which ones they would have you to use, it comes from just practicing using identities and manipulating. There's really nothing I can do or tell you that's going to make it any easier, but it's about recognizing those little things and manipulating it. All right? Yes. What happened to, the cosine? Because I made it into the double angle identity, I can condense it down to the double angle. So 2 sine x is sine 2x, right? So I condensed it. So this is the double angle expanded. This is the double angle condensed.